Hello and welcome to the SaturdayMP show, episode number 31, being recorded mostly live, February 5th, 2024. And this is a show where we help you ship secure, high-quality software faster. And I'm your host, Chris, and today I don't know if we'll meet that goal or not, kind of the mission of the thing, but we're going to play around in a game. We're going to answer a question that several videos ago I did the human resource machine game, and I got some feedback and some questions and a possible solution to one of the problems for the game. So I think we're going to try and answer that today is what we're going to do from Ndidi. So Ndidi's written a couple times about different ways to solve, especially this Fibonacci problem that I keep getting stuck on, where we try to do it in 19. For those who don't know, we'll go over the steps a little bit more, but it's basically a game where you're simulating like you're writing assembly level code, and you have to move items around from registers, and you have very limited instruction sets. So Ndidi has some suggestions on how to solve one problem, and kind of reading over their suggestions before, I get the impression that maybe they don't have the game. So it makes this even more impressive that they sat down, because I'm assuming if Ndidi had a copy of the game, they would just sent me the solution, but it looks like they just sat down with paper and wrote this out. So that's even more impressive, Ndidi. And please don't feel wrong. Like Ndidi has a suggestion last time that turned out it didn't work, but please don't feel wrong or feel bad about that. Just keep the suggestions coming. This is amazing, because even if this suggestion down here doesn't work, worst case scenario, maybe it'll give me some inspiration and others to actually solve the problem. And I haven't had a chance to play Human Resource Machine in quite a while, so we'll boot that up here and jump back in and try and remember how it works and try this solution here. And if it goes well, if we solve the Fibonacci one, this is the mostly live part. If we solve the Fibonacci problem relatively quickly, then we'll jump we'll try and solve a couple other problems, I think. Because it's a fun game, and I haven't had a chance to play it in a couple weeks, so I'm looking forward to getting back into it. Just a couple things before we jump in. If you kind of like these videos, please hit the like, share, subscribe, all the buttons there. And if you have any questions in the future, you can send an email to ask@SaturdayMP.com, it should be down here somewhere. Yeah, right here. So you can just send an email to there, ask@SaturdayMP.com, or you can just leave comments in the YouTube channel, and I would love to answer, discuss game-related problems, but ideally more about software development, questions about Docker or Rails, or just any software development problem that you happen to be having. I'd love to dig into it and try to help you solve that. So, okay, so I've copied all this into Notepad here, so I have Ndidi's solution here, so I'll put that off to the side. And then there might be I try not to edit these videos too much, just because I think there's too many highly edited videos out there that make software development look super easy. And I guess because I'm kind of lazy. But I might have to pause it here in a brief second. Well, we'll try launching it. We'll see what happens. We'll see if the human resource machine launches successfully or not. So let's see. I'm actually really excited to play this game again. Is it firing up? Let's see. Oh, it's really thinking hard. Could be maybe because I have recording going too. Oh, there we go. Oh, that's a little loud. Okay. How do I get to the sound? Well, hopefully that's not too loud. I might have to edit the sound. the sounds. Maybe there's no way to edit the music video or the music sound. So, all right. So those that never played the Human Resource Machine, like I said before, it's basically an assembly game. You try or simulating like you're an assembly, or like a computer writing assembly code. And you have these really limited instruction sets kind of shown over here. These are the instructions we can... Oh, why can't I click on anything? Oh, there we go. Okay. On the left here that we can do, and then we basically build a little program to try and do what the problem we're trying to solve. For this one, It's Fibonacci. So for each thing in the inbox and to the outbox, the full Fibonacci sequence up to but not exceeding that value. For example, if the inbox is 10, the outbox should be 1, 1, 2, 3, 5, 8. So the Fibonacci sequence, for those who don't know, is basically this number 2 is the sum of the two previous numbers. So 1 plus 1 is 2, and this 3 is 1 plus 2 is 3, 5 is 2 plus 3 is 5, and so on and so forth. So this is like, they love using this problem in, if you're taking computing science courses, they love this problem. And so when you run this program, again, this is for those who already know about this, you could probably skip ahead a little bit, but you basically, it's going to go through this problem on the left here. If I can, why can't I scroll down here? Oh, there we go. But the fellow will just walk through, he'll solve it based on where I've turned it from, and then speed this up a little bit. And these problems, you can just kind of solve them, and then you get to move on to the next level. But then there's also challenges where you try to solve them with either the least amount of what are the two ways that they call it here? Right, size and speed, I guess. So the one is to use the 19 or fewer commands, and the speed challenge is do less steps. So you can use more commands, but when your program executes, you use less steps. So we easily got the speed challenge. We did that like right away. The one I've been struggling with is the size challenge. So the first one, this first program here, I have two going on here now. This first one was the speed challenge, and this is the size one. So let's see. Let's start implementing Indidi's solution here. What's the best way to do this? Well, let's run this one real quick and let's see if this one even works. Nope. So that one fails right off the bat. What about this third program here? No, okay, so both of them fail, so it doesn't really matter. Okay, so let's just clear this one, I guess. So let's clear the second one. Yes. Okay, so Indidi's solution is we have label 1, which is bump 9. Yeah, and yeah, you can watch some of the previous videos about how kind of the ways we solve that. I don't think I'll go into that too much. And now this is... Oh, alright, I have to write this with the mouse. Set up. There we go. Alright, so they're set up. And then they have copy from 9, which is what we need to do. Whoops, copy from 9. Done. And then this is like left, right. I use the L for left, R for right, and I can't remember. I think this was the original input in, because we basically have to make sure, we have to check to make sure when we've actually exceeded this value. So then we copy to L, copy to R. Basically, we'd initialize everything. And then we'll grab our first one from the inbox. And we'll copy that to the input. Okay, so that all seems right. So we'll just run this real quick just to make sure it does what it does. Right, so that setup looks fine. So we got 1, 1, 9. Everything looks good. Okay. And then they have a label here. This is the loop. Alright, so in this invariant, loop invariant holding in. Alright, oh yeah, because when we get to here, we're holding the input. Okay, that makes sense. And can I drag this out? Yeah, so just a reminder. This is what I'm reading from. So you can read it in the comments section in that old YouTube video if you want. So they're holding input, that's fine. Here we first test it for already done. Calculate input minus L. So that'll give us that'll give us a positive number. Okay. Let's see if this works. So subtract L. And then jump if negative. Then where do we jump if negative to? To setup. So I guess we'll go here. Oh, that's interesting. Okay. So basically this loop won't do anything right away. What do we do after that? Then if it's not negative, then we copy from L. Grab the output values. And then we outbox it. Right, because we have to put in 1, 1, 2. Okay, yeah. So that'll be 1, so 1 will end up there. So far it's working. And then we have to copy from L again, because once you outbox it, you've lost it. And then we have to add it to R. Where's the add? There we are. Add to R. And then we need to copy to R. Okay, so let's just see what this is doing here. So we got our setup. So we're subtracting. So 17, it's not negative. That's fine. Then we get 1. We throw it in there. Done. And we got 2. And we put 2 there. Okay, that's fine. Copy to R. Okay. So then we'll subtract L. And then we copy that to L. Oh, that's interesting. Okay. What's that going to do for us? So we need another 1 here, though. Because it's going to be 1, 1. So let's see. So 2. Whoops, what happened there? So we got the 2. Put that there. That's okay. 1. So we got the copy to L. Copy from input. Oh, why are we... And then jump to the loop. Huh, okay, well, let's see what... Even if the... Oh, it's... It's hard for me to tell if this is going to work, but let's see. Even if it doesn't, maybe it'll give us some inspiration. Because I've really struggled with this one. So that's good. Now we need another... I wonder if we're going to end up with another 1 there. So 5. So this is the check. Okay, so we're not... That's fine. Oh, good. We did get 2 1s there. Wow, okay. Add... 3. Oh, okay. I think I see what you're doing there, indeed. You're doing the... Instead of... I think before I was copying, like, I would copy the old value from R to there, and then put the new one into R. But indeed, he's just doing the math for each one. Oh, okay. Because the next one will be 2. Oh, wow. This might work. So it's not greater. That's fine. What's the next one? 3. Yeah, this is looking pretty good. Okay, do we want 5 up to but not exceeding? So it's greater than, or it's less than or equal to. Okay, so we do want the 5 to appear there. Okay, so let's And we have this if negative. Oh, yeah, that's right. Okay, yeah, because indeed he made a comment there about that. Yeah, this whole one here. Oh, wow. Indeedy, this is looking this is looking fantastic. So 0. 0 is not negative. That's fine. Yeah. Throw that in the outbox. And who... Like, we're basically going to set up for the next one, but we're not going to do anything, so who cares? So we take 5. Now this should be negative. And then we need to set... Oh, okay. Yeah, because then we'll need to set up again. So, it's good. 1, 2, 2, 3, 4. Yeah, that's all good. We set everything up again. Put 20 in there. Ah. I'm just going to go this one a little faster. Right, we got 1, 1, 2. Oh, yeah. Let's just see if this ends properly. We might have to tweak the ending a little bit, but 12 or 8 8 plus 5 is 13. Yeah, that's great. Wow. Indeedy, thank you very... This looks... Yeah, okay. Because we got to the inbox is empty. Oh, wow, it's 17. Oh, we almost did the speed challenge, too. Oh, Indeedy, thank you very much. That was amazing. That was great. So, again, if you don't actually have the game and you figured that out, that's even more impressive. So, wow. Thank you very much for this fantastic solution. So, yeah, that was very inventive way where you did... I think you suggested that the last time, too, that didn't quite work. The solution where you do some of the... Let's just hear. Because this is really interesting. I really like this. The setup. So it's kind of a cool way to check. Nothing. Yeah, like I like the way you're doing the math here. Because otherwise I have to spend extra, when I was trying to do the solution, I'd have to spend extra steps. Like I would basically need three variables to store left, right, and then kind of what it was before, and then kind of shift them all. But that took quite a few steps to like copy and then put like the old R here, put the new R, and then shift everything down, or vice versa with the left. But this actually doing the math down here is very cool. Wow! So thank you very much, Indeedy. Okay, well, I don't know. Let's run this, just run real fast, just because it's awesome that it works. So yeah, if you figure this out all by yourself without looking at hints online and without having access or without actually having the game, that's really amazing. So thank you very much. Okay. Wow, okay. Oh, that was pretty quick. That's great. Let's go solve some more of these problems. So again, I didn't record videos of me solving all of these. I just solved some of them. I don't know if you want a video of me solving all of them, let me know. But I did this 3 sort, so it looks like last time I played I got this done, but I haven't got the speed or the size challenge. So let's see. Let's see if we can get one of these done. So 3 sort. For each 3 things in the inbox, send them to the outbox in order from smallest to largest. Okay, so if we got like 9, 6, and 2, so we'd have to put 2, 6, and 9 would have to end up there. How do I get an example? There we go. Right. 9, 4, 1, 1, 4, 9. Okay. 1, 5, 7, 1, 5, 7. We have to handle negative numbers, it looks like. So that's all good. So it looks like I got a solution that works, but doesn't meet either of the... Yeah, I didn't bother. I don't know why I put a 0, a 0 there. Alright, so let's just double check that this works. So we grab one of each. And so what are we basically doing? Oh, it looks like I'm just basically doing sort. A sorting algorithm. Right. So we're just comparing each one and sorting it. And then once we're happy with where everything's sorted... Okay. So I don't know, we're probably using like bubble sort or something. Some very inefficient sort. Ooh, we're close to the size. Oh, we're way off the speed. Holy jeez. Okay. Okay. So let's do this. Copy that. There's, we have it. So that's the working one. We'll try this one to be the size one, I think. Paste. So we set all three of them up. Do we even need to do that? Right, because we need 269 to come out of this one. How would I... Definitely need to grab some from the mailbox. Put it somewhere. Done. Guess I could compare these two right away. Just to figure out which one's smaller. Okay, let's look at my sort algorithm here. So, well, we waste a step at this copy from 2. I guess we could go the other way, because we have 2 in our hand. That would, if I did this backwards. Because what I look at... how does my algorithm work here again? Let's see. Okay. Okay, so we're looking to see which of these two, 9 or 6, is smaller. So 6 is smaller than 9, so we need to move 6 and 9 around. So that's what that does. Oh yeah, do the number. So I wonder if we could do some of the math that Indeedy did the other one. Okay. Right, so now we have 6 and 9, but we need 2 to be... Oh, okay, yeah, and then we're going all the way to the top of the algorithms. What is that called again? Bubble sort? Start all the way at the beginning. Those two are fine. So then I can compare these two. They're wrong. So swap them out. And then I would need to... Yeah, and then we need to go all the way to the beginning, because we need to move 2 over there. Okay. Well, I wonder if I could get to the size one by just... I could just do this. Now I'm at 0. I don't need this copy from 0 because I have 0 already. Alright, would that make our size? Let's see. Oh! What did I do wrong there? Interesting. Okay. So 0, -3, 9. Okay. Go a little faster there. 0, -3, 9. Done. So -3. It's not negative, so swap the positions. Done. Zero. Oh wait, what happened there? If it's negative, it's not, so this should swap the 2. Okay, that's all good. Oh, I haven't. Oh, I don't reset this 0 here. Oh, okay. I have to grab from 0 all the time. So I do need that copy from 0. Dang it. Okay. Stop this. Okay. Do I do some sort of comparison where, like Indeedy did with the math back there? Let's see. So if we put 7 there, 5 and 1. Like this is already sorted. What's a better sort algorithm than what we have right now? So let's say if I put 7 at 0 and then 5 at 1. Or I could compare it 7 at 0 and then I could compare 5 to 7. Which one is bigger? Okay, well, let's just try clearing this. Okay, so inbox, copy to 0, sure. Inbox. Subtract 0. Now, it's going to be negative. So this is subtract 0. So that's, those two are negative. So I need to move 5 needs to be on the left. Or 5 needs to be outputted before 7. Well, maybe I put these in both of these spots here. Okay, so now I have 7 here and here. I subtract if it's negative. Or, okay, let me take... We'll do the comparison one. This is the comparison. This would be 1, 2, 3. So ideally 1 is the smallest, and this is always the comparison one. Now the one we're going to inbox, we're going to copy that to the comparison. And we'll subtract 1. If copy to comparison, yeah, so we'll have 7 and 5. Now it's 5, so we subtract. 5 is less, that's negative. So now we want to move these little. Move this one to there. Okay, so then if it's negative, we'll just write this out and see what happens. So no, if it's negative, I guess you could just add it again. Add to L. Copy to... No. Ah! I need to move 7 first, so I need to copy from 1. I need to copy to 2. Copy from here. Right, but it's not very good, because we'll have to do this. Because I don't think it handles if they're all... I think it fails if one of these is empty. Like, no, maybe I should just initialize them all to 0. And then I'll have something in each one. And then we could just, when we do the copy, we bump, 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 doof. Oh, okay. So we always have the lowest one in the left. Okay, well, let's try that. So let's... Oh, I don't have anything to put in there right off the bat, though. I can't put that to 0. Oh, shoot. Dang it. Okay, but if we did 7, 5, and 1... I guess we would just put 7, 7, 7 in each one. Blah, blah, blah. And at least they're all initialized. Okay, well, let's try that. So let's inbox 1, 2, 3. There. They're all initialized to 7, 7, 7. Now when I get 5, I can compare it to 1. Yeah, and then I can just move everything. Bump, bump, bump. Like the loop would be move 1 to 2, 2 to 3, and then put the comparison in there. Okay. So that would be our loop. It's basically shifting everything along. Is that going to work if we have like some weird... Like once if we had 5, 7, 1. So we put 5, 5, 5, 7. So 7 would goes here. What does it go? Oh, yeah, right. If it's bigger, what do we do? Okay. I need a sort algorithm. It's more efficient than what I got here. Probably would have been better at this if I wrote this shortly after university, because we went through a bunch of these algorithms. Okay, well, we always know there's an array of 3. So up, 7, 7, 7, done, done, done. Now let's grab the next one. So this is technically a sorted array. We know it's sorted. Like, if we just keep that array sorted the whole time, maybe that's okay. And then okay, and then we subtract it. Okay, and then if it's negative, yeah, we gotta find out where to put it in here, I guess. So if it's negative, that means it's smaller, so it needs to go to left, so we need to bump everything over 1. So we'll just put it in C for now. If it's negative, then we need to copy 2 to 3, 1 to 2, boom, done. Yeah, so that's kind of the sucky part, is then I'd have to write... Oh no, that's okay, I think. Alright, if it's not negative, go to the next one. Yeah, this is where I wish we had variables, because like an index into this array. Okay, and then let's just see what happens with this. So 7, 7, 7, done. 5. One. That's the third. Oh, I guess it's the third one. So we don't. Oh, yeah. I guess we can't really do that because we don't know when to stop. Oh, yeah. We will have to put all 3 of them out there. Okay. Oh well. Yeah, we just gotta figure out what sorting algorithm we want to use here. Okay, so 1, 2, 3. And then we compare 3 to 1 to 2. Let's... Oh. Let's just do it this way. Okay. So we go 7, 4, 2. Boom, boom. Oh, I'm trying to remember all my sort algorithms. Alright, so 2 is less than 4, so 2 can stay there. Yeah, like we basically have to go through it until... Okay, so if we subtract 1 from 2, if it's negative, then we need to switch them. If they're not negative, then grab 2, subtract it from 3. If that's negative, we need to switch those two around. Otherwise, we're just done. So I guess we should, because we want to outbox them. I guess it doesn't really matter. We can maybe reverse this after, but copy from 1, outbox. Copy from 2, outbox. Copy from 3, outbox. And then when I go all the way back up to setup again. So that'll probably work for this initial one. Let's see. Oh, no. Oh, it is negative, so that means leave it. So that's this guy here. Alright, so negative... Oops, I got that backwards. So negative just means leave it. Maybe I should do it the other way. Is that actually what I want? If it's negative, I want to swap them. Okay. So if negative, go here. Oh, this is really hurting my head. It's so much easier when someone just gave me the solution. Subtract 3. If they're negative... No, I like the other way. Let's go back to the other way. Just... It's hurting my head too much. Okay. Or sorry, 3, 2, 1. So if they're negative, you don't do anything. Boop. This is probably pretty much what we did last time, isn't it? I don't know. It's negative, don't do anything. Jump if negative. Boom. So then we'll copy from 2. And we will subtract from 3. Go here. Let's just get this for now. Okay. So if it's negative, then we don't do anything. And again, if it's negative here, we're done. We just go right to our output. Just outbox all three of these. I do wish this thing had some sort of methods. This is kind of annoying. Okay, so this should work for this. Okay, that's great. And down here we would need another jump to go all the way to the setup again. Okay. Now, the tricky part. If it is negative, we just need to swap the two. So we have the subtraction of 2. Okay, let's just do a simple swap because that math confuses me sometimes. So, subtracted from 2, so we can just add to 2 again. That gets us back to whatever value of 1 was. And then we can sure. Copy 2 there. And then we would just basically need to do the same thing here, but down here. Oh, it's a lot of steps. How many steps did I do for this other one? Oh, 35. Oh, it's less, I guess. Maybe, well. Alright, so this we add 3. At least I have to copy this code here. But only with copy from 3. Oops. Copy to 2. From C. Well, it's less. I don't think this will work, but let's see. Yeah, because that 2 needs to move down 1 more. So we compared 1 and 2, swap them around. I wonder if I should just build another array. Like, what happens if I... Let's see. So 762. Should I just go along to see if it's the biggest? And swap 2? Oh, maybe that's what I should do. Like, just, if it's the biggest, just find it and swap it out. Okay, so 1, 2, 3. That one's already sorted, but what I should really do is I should take 1 and compare it to all of them, make sure it is actually the smallest. Is that what I should do? Yeah, this fails because yeah, it's expecting 3. That's where my other algorithm, I went back to the beginning. Like every time I changed the array, I had to resort it. So okay. So okay, another solution is maybe let's try when we do the comparison, we'll see if it's actually smaller than everything in there. If it's not... Okay, so let's clear this. Oops. Now, I guess I don't need to copy this. Well, okay, let's just put it there. 1. Now, we want to compare 1 to all... So if it's less than, leave it. So if it's negative, leave it. Two, so this would be 2, 5, 9. How do we compare them to all of them now? So less than, leave it. If it's not, check the next one. Okay, so, man, I'm not talking because I'm thinking here. So, 2, 5, 9. I need 9 to, like, get all the way to the top there. 5 can stay where it is. 9 and 2 basically need to switch. So I compare 9 and 5. Those two would have to switch. But I'd also compare 9 to 2. So I know it's bigger than all of them, and I could just switch it. Okay, let's try that. So if it's negative, then subtract. Oh, I need to actually add 2 and subtract 3. So if that's the case, then that's 0, right? Like, okay, so we know that's the smallest number because it's smaller than all the other ones. Okay, so everything's good. Nothing to switch. We could just output it. If there is something to switch, so let's... Let me just outbox these 3. Okay, now and then go all the way back up and reset. So this should handle this first case, no problem. Now, okay, so we had 8, 6, so 8, 6, and 2. So 8 is bigger than 6. Now is 8 bigger than whatever's in 3? Okay, so let's add 2. And then let's subtract 3. And then if it's negative... if it's negative, it just stays where it is. Oh, no. Okay, so if it's not negative, then we swap 1 and 2. Right? Just if it's negative... right, let's just go through this real quick. Okay. Back to 8. So it's bigger. Yeah, so we should swap 8 and 3? Sure, let's try it. It's not negative, so add 3 back on there. And then sure, copy to C. Alright, let's see what that does. Copy 2, 3. Okay, interesting. So now we know we have the highest one here, because it was bigger than everything else. That worked, but I'm sure it's not going to work for... There's going to be some cases it doesn't work. Yeah, like this one. Yeah. Okay, 812, so... So it's negative here, then these two need to... Oops. Do nothing. Alright, let's see. So this one will work. What's this next one? So 1... Yeah, so the other thing we know is that we have the biggest one at the end. That's what we have from here. I really get confused now. Writing in these loops is really hard for me. Because would it be... should we do the small... Like, okay, so we did 1. Compare it to 4. Like, this will work, but it's not what we want. Yeah. Oh, we're close. Okay, so... Oops. I'll go a little faster. Okay. Yeah, so 0. Not negative. Okay, so we need some logic in here to compare these last two, I think. So... if it's negative... if it's negative, then doesn't do anything. But if it's not negative, then we just swap those. Oh, what happened there? Oops. Huh. I screwed it up somehow. 861. Okay. Back a little faster. Okay, so we got 8 at the end. That's great. Oh, but we're not. We added... yeah, that's going to confuse the heck out of it. So... just making this worse on myself. Okay, I'm gonna clear this again because I'm getting super confused. Yes. Okay. Inbox. Oops. Now do I... Huh, let's get rid of that. Okay, so let's take this next one from the inbox. And then let's subtract it from 1. If it's smaller than 1, so let's just double check what we got here. Okay, so it's smaller. It's smaller. So if it's negative. If it's, let's put it to 4. If it's smaller than that, then those two need to swap. Oh, it's in 4 already. So Do I just go back to like the bubble sort? Like, three, two, one. This is what I struggle with. Okay, that's a real pain in the butt one to do. So let's do that. So we'll assume 1 is always the smallest. We grab the next one. We subtract it from 1. If it's... we have this jump if 0. Whoops, jump if negative. Copy to 3. Ah. Okay. So we just add and sort these as we go along? Is that what we do? Now this next one, we're going to pull from the inbox. Oh, can we just do this? No, that won't work, I don't think. Because we have to copy to 3 after. We have to bump everything down. Yeah, we have to move 2 to 3. Oh my god, this is so tricky. Okay, so what did I just did a bubble sort here. It's so hard to read that. Jump if negative, jump if 0 too for some reason. I don't know why I did that, but... why did I do jump if negative, jump if 0? That's interesting. maybe that'll fix it. Okay. Well, this has been an hour video, and you just watched me struggle with this, so I think it's probably a good time to wrap it up. So sorry, but thanks again to Indeedee for finding the solution for that. Maybe you can find a solution for the 3-sort problem. I think maybe I'll play around with it a bit more on my own too, to think about it. So yeah, if you have any other questions you would like answered in a future video, give me a shout at ask@SaturdayMP.com, or just leave some comments in YouTube channels below. If you enjoyed this video, enjoyed watching me struggle through the, what was this one called? The 3-sort problem, where I'm trying to figure out a nice sorting algorithm in assembly, which apparently is really hard for me. Hit the like and subscribe button and all that stuff. If you have any constructive feedback, you can send an email to ask@SaturdayMP.com. Just constructive feedback, not mean stuff. There's already enough mean people in the world. You don't need to become one of them. And yeah, I hope you enjoy the rest of your day, and I will talk to you later. Goodbye.